Today's lesson is on Venn and tree diagrams. Our objectives are to create Venn diagrams to calculate probabilities and to create tree diagrams to apply Bayes' theorem with a maximum of 3 events to calculate probabilities. A set is a collection of numbers or objects named by capital letters. For example, set A. We can use any letter we want, but we have to make sure it's capitalized. A finite set is a set having a finite number of elements, which means we can count the number of elements in the set. For example, 1, 2, 3. An infinite set is a set having an infinite number of elements. You'll know if your set is infinite because it will have the ... at the back to show that it's going on forever, or it could be at the front, or it could be at both the front and the back. This little sideways, like squishy C with a line under it means subset. A set is a subset of a set B if every element in A is also an element in B. Without the little line, it means it's a proper subset. It means that if A is a subset of B and A does not equal B, then A is a proper subset of B. So for example, if B is the set 1, 2, 3, 4, A can be the set 1, 2, 3. Since all of the elements in A are also contained in B, it's considered a subset. Because A is not identical to B, it's also considered a proper subset. This little weird E looking thing, or that symbol with a slash through it, means is an element of or is not an element of. So for example, 1 is an element of A. The squiggly brackets with nothing inside or a 0 with a slash through it means the empty set. So we could say that set C is the empty set, and technically set C is also a subset. So it's a subset of B because the empty set is a subset of every set. If you see the little n in front, that means the number of elements in set A. So if I were to say NB, that would be 4 because there are 4 elements in set B. U is the universal set. That's the set out of which we're taking all of our other sets from. And we'll talk about that a little bit more in a bit. A prime is the complement of A, so it's the set of all elements in the universal set, not in A. So that's why it's important to know what the universal set is, so you can find the complement of another set. So for example, if our universal set was all positive integers, set A could be all even positive integers. And I spelled that wrong. Integers. And that means that A prime would be all positive integers that are not even. This symbol means intersection, and this symbol means union. The important thing here is this is not an N, this is not a U, so there's no line on it. You don't draw an intersection like that. That's wrong. That's an N. That's not intersection. Intersection is like a loopy thing, just like that. No line. The same with union. That's a union. This is not a union. That's the letter U. Okay, union. Good. Okay, that's what you want to do. Sets can be represented diagrammatically using Venn diagrams. Each individual set is represented by a circle, and the universal set is represented by a rectangle, which encloses all of the sets under investigation. All pieces of a Venn diagram must be labeled. You'll notice the U, that's our universal set. If you're ever drawing a Venn diagram, you have to draw that. You also have to draw the rectangle around the outside. Mandatory. Every Venn diagram must have those two things. Now, the first Venn diagram represents subsets. all elements of one set are contained within the other set. So you can see that set B is completely inside set A. So that means B is a subset of A. Intersection are the elements in set A and set B. So it's this little section in here that's in both. That would be written as A intersect B. Notice we have the U and the rectangle drawn around the outside. A union is all the elements that are in A or B or both. So that's written as A union B, and that would be A, B, and the intersection. Disjoint sets are mutually exclusive, meaning they have no common elements. So those circles are drawn with no overlapping region. There are 4 regions in a Venn diagram which contains 2 overlapping sets A and B. One is things that are only in A. Another one are things that are only in B. Then we have the things that are in both. And lastly, the one that everybody forgets are the things that are in nothing. Or not nothing, but neither. So they're in the universal set, but they're not in A or B or both. If we have 3 overlapping sets in our Venn diagram, then we have 8 regions. We have only A, we have only B, we have only C, we have A and C, we have A and B, we have B and C, we have all 3, and then lastly, we have the outside, which is none of the 3. Numbers are often placed in the appropriate regions on a Venn diagram to solve problems. So, for example, 1. The universal set is 1,000 Americans. A is blood type A, which is 450 Americans. B is blood type B, which is 140 Americans. And A intersect B is blood type AB, which is 40 Americans. So we'll start with the 40 Americans that fall in there. Then there's 140 in B and 450 in A. Now, you would think we're done, but we're not, because our universal set has 1,000 Americans. We should probably put an S on that in it. So if we add these numbers up and subtract them from 1,000, that means that we have 370 people in our universal set who do not have type A blood, type B blood, or type AB blood. Elements not in the set A are called the complement of A. So, for example, 2, we want to shade A prime. So the trick with shading A prime is it's going to be the B circle that's only B, but it's also going to be everything around the outside. So don't forget about that region. NA union B means the number of elements in the union of set A and set B. So the union is the number in A plus the number in B minus the overlapping, which is very similar to the probability that we were doing the other day. Just like the probability, if they're mutually exclusive, there is no intersection. Therefore, we don't have anything to subtract out. So we can just do the number in A plus the number in B. For example 3, we have, of the 540 seniors at Brown High School, 335 are taking mathematics, 287 are taking science, 220 are taking both mathematics and science. Draw and label a Venn diagram to represent this information. How many students are taking neither mathematics nor science? So if I draw my Venn diagram, remember we always start with a rectangle and my U for the universal set. I have a circle for math, a circle for science, and they overlap. When we start filling in, the best thing to do is to fill in the people taking both things first. So there's 220, I didn't make this very big, 220 students taking both. Then there's 335 taking math. Well, those 220 are already included in there, so 335 minus 220 tells us that there are 115 that only take math. For science, there are 287 taking science. If we subtract the 220 who are doing both, that leaves us 67. If we add those numbers up and subtract them from 540, that gives us 138 for the region outside. And our question says how many students are taking neither. That's 138 students. In a survey, 113 business executives were asked if they regularly read the Wall Street Journal, Business Week magazine, and Time magazine. The results of the survey are as follows: 88 read the Journal, 76 read Business Week, 85 read Time, 42 read all three, 6 read only the Journal, so this is an important word, only, 5 read only Business Week, and 8 read only Time. Draw and label a Venn diagram to represent this information. So we're going to draw our rectangle, label it with the universal set. Now we need 3 circles that all overlap each other. One is going to be Wall Street Journal, the next is Business Week, and the last one is Time. Here, it's different because 8 read only Time, so we can just put the 8 right in that circle that's only Time. 5 read only Business Week, 6 read only the Journal. 42 read all 3. So now this is where we have to do a little bit more math because we know 88 read the Journal. Now, the Journal circle is actually the Wall Street Journal. So maybe I should call that WSJ, the Wall Street Journal. That's this circle right here. So that circle has to add up to 88. So what I can do is I can label these 3 sections as A, B, and C. So the entire Wall Street Journal has to add up to 88. So that means 88 has to equal 6 plus 42 plus A plus B. Next, we know that Business Week has to add up to 76. So this whole circle has to be 76. 76 equals 5 plus 42 plus B plus C. Then our last one is Time. Time has to add up to 85. So 85 equals 42 plus 8 plus A plus C. So if we clean those up, we get A plus C equals 40. A plus B equals 29. B plus C equals 35. Now from here, you have to solve this using a system of equations. You can either do this in the calculator using a matrix or with substitution. Elimination won't really work here because if we eliminate with the top 2, we're left with B and C still, so then we would jump right to substitution from there. So I guess you could do it that way if you really wanted to. Anyway, A, when you solve this, ends up being 17. B is 12, and C is 23. What I would like you to do is to make sure you can find those 3 numbers. So now I'll add them to my Venn diagram. How many students are taking neither? Apparently I have a copy paste error there. We don't need those. How many people read none of the 3 publications? Well, if we add all of these numbers up, and I guess that should be the word many, not many. How many people read none of the 3 publications? Well, if we add these up, they all add up to 113. In the problem, it said 113 executives were asked. So that means there are 0 people left over. So that means no one read none of the publications. Next, we're going to talk about tree diagrams. So with tree diagrams, we usually have a situation where one thing happens and then something else happens. Whereas with Venn diagrams, we're just kind of talking about like two things that are going to overlap each other, but they're not really sequential. When you're talking about sequential things, that's more when you want to use a tree diagram. So a factory has two machines making widgets. Do you know what a widget is? Maybe you should Google it. Or maybe you don't have to. A widget is just like any little thing. Okay. So any little thing that doesn't really need a name. The older machine has a larger capacity, so it makes 60% of the widgets, but 6% are rejected by quality control. The newer machine has a 3% rejection rate. Find the probability that a randomly selected widget is rejected. So we have two machines. We have an older machine and a newer machine. So for the older and the newer, 60% of the machines are made on the older machine. 60% of the widgets are made on the older machine. 40% are made on the newer. If they're made on the older, 94% are accepted and 6% are rejected. For the newer machine, 97% are accepted and 3% are rejected. Now, to do math on the Venn diagram, if we're going down a branch, we multiply. So we asked, find the probability that a randomly selected widget is rejected. So there's two ways a widget can be rejected. It can be an older or it can be a newer. So as we're going down the branch, we would multiply those together. So that would be 0.6 times 0.06 for the top branch. The bottom branch would be 0.4 times 0.03. So this would be 0.36. This would be 0.12. Oh, my decimals are in the wrong spots. This would be, I forgot to move it a third time. So we have 0.036, and this would be 0.012. I missed a decimal spot place. So now we add those together. So if you have two branches that you're putting together, you do that by addition. So 0.036 plus 0.012 is 0.048, which means that it is 4.8% are rejected. The school tennis league consists of 12 players. Daniel has a 30% chance of winning any game against a higher ranked player and a 70% chance of winning against a lower ranked player. If Daniel is currently in third place, find the probability that he wins his next game against a random opponent. So the first thing we have to do is we have to figure out whether the person he's playing is higher ranked or lower ranked. So altogether, there's 12 players. Daniel is one of those players, so he doesn't count. So there's 11 players. So because he's in third place, 2 out of the 11 players are ranked higher than him, which means 9 out of 11 are ranked lower. An important thing to take note of, the branches have to add up to 1. So 2 11ths plus 9 11ths is 11th 11ths. They have to add up to 1. Now from there, if he's playing a higher ranked person, he can either win or lose. The same is true as if he's playing a lower ranked person. The probability that he wins is 30%, and so the probability he loses is 70%. If he plays a lower ranked person, those probabilities switch. Okay, so when we put these together, we want to know the probability he wins. So winning can happen two ways. So for the top, it's 2 11ths. Now, 30%, like that's kind of annoying to do like 2 11ths times 30%. So we can turn that into 3 out of 10 because it would be 30 out of 100. So that would be 6 out of 110. On the bottom, it would be 9 elevenths times 7 tenths, which would be 63 out of 110. Now we add those together, so we get 69 out of 110. Now, I would leave it like this. I would leave the fraction. We discussed this in the last video. Fractions are great. It did talk about percents though, so if we change this into a percent, it would end up being 62.7%. Now, if you don't have a calculator, like don't even bother with that. Just leave it 69 out of 110. That's fine. This is Bayes' theorem. So Bayes' theorem says if I have the probability of A given B, so that means I'm going to find the probability of event A given that event B happens. So now these are definitely sequential. So from here, it's the probability of A times the probability of B given A divided by the probability of B. Now, if you look at the Venn diagram I have here, you'll notice that nowhere in here do I have the probability of B given A. So this tree diagram is backwards from the formula. So the best way to do this, rather than changing the entire tree diagram, is to make the formula match the tree diagram. So the probability of B given A is going to be equal to the probability of A. Sorry, we're switching everything. So it's going to be the probability of B times the probability of A given B over the probability of A. So we just have to switch all the letters to the opposite places. And so now it matches the tree diagram. And it makes a lot more sense if you can see this in a word problem. So in the problem, here's what happens. Sam travels to school by bus on 70% of school days and by car on the other 30%. The probability that she is late is 0.05 if she travels by bus and 0.12 if she travels by car. On a particular day, Sam is late for school. What is the probability she traveled by bus? So we're going to break this up. We have our bus. We have our car. She's on the bus 70%, so we'll use decimals. We'll say that's 0.7. She's in the car, 0.3. She's either late or not late. Either way she does it. So the probability of being late on the bus is 0.05, which means being not late is 0.95. The probability of being late in the car is 0.12, which means being not late is 0.88. Now, the question says, on a particular day, Sam is late for school. What is the probability she traveled by bus? So that means find the probability she traveled by bus given she was late. So to do this, it's the probability of bus and late divided by the probability that she's late. So the probability that she was late because she was on the bus is this branch up here, late in bus. So that would be 0.7 times 0.05. Now, the probability that she's late, well, there's two ways she can be late. That's 0.7 times 0.05 plus she can also be late down here. So that would be 0.3 times 0.12. When we do this math, we get 0.035 over 0.035 plus 0.036, 0.035 over 0.071, which is 35 over 71. If you don't have a calculator, you can leave it like that. 49.3% chance that she traveled by bus given she was late. The Mendham Minutemen want to be sponsored by Pepsi. If they finish first in the league, there's a 90% chance they will be sponsored. If they come in second, there is a 20% chance they will be sponsored. And if they come in lower than second, there is a 5% chance they will be sponsored. There is a 30% chance they finish first, a 20% chance they finish second. At the end of the season, they are sponsored by Pepsi. What is the probability they finished first in the league? So the first thing that happens is they have to finish first, second, or lower than second. So we have first, second, lower than second. So the probability of finishing first was 30%, second was 20%, and lower than that was everything else. So that's 50%. If they finish first, there's a 90% chance they're sponsored, which means there's a 10% chance they're not sponsored. If they finish second, there's a 20% chance they're sponsored, which means there's an 80% chance they're not sponsored. And then if they finish lower than second, there's only a 5% chance they're sponsored, which means there's a 0.95% chance they're not sponsored. Now, at the end of the season, they are sponsored by Pepsi, so that's what's given. Find the probability they finished first. So we want the probability they finished first given they're sponsored. So that's the probability of first and sponsored over the probability of sponsored. So there are 3 ways they can be sponsored. First, second, third. So those 3 ways are going to be added together in the denominator. And then the numerator is when they come in first and are sponsored. So when we put this together, first and sponsored is 0.3 times 0.9. The denominator gets that 0.3 times 0.9 plus 0.2 times 0.2 for our second option plus 0.5 times 0.05 for our third option. When we do all of that math, we end up with 0.27 over 0.335, which is 270 over 335, which is 80.6% chance. That's it for these notes. Work on your homework with your groups. Please come see me if you have questions.